Hello students, Miss Slyman here, and we're into our Unit 8 where we're looking at other functions, and this is syllabus topic 6.5, so we're looking at functions of the form f of x equals ax to the m plus bx to the n, etc. So note, in the test you're always going to be expected to be able to use graphical methods including your calculator to solve, so you're not going to need to know how to do any of this without your calculator. So we're going to focus on using our calculator to help us graph these functions and think about them. So first of all, a polynomial function has a general equation. So similar to this one, we're going to say a polynomial has a general equation of y equals ax to the n plus bx to the n minus 1. And we're going to keep going all the way down, decreasing our powers of x until we get to no powers of x. So we're going to keep going down until we have some letter, I don't know which letter it is, let's say that we go, I don't know, to m, and then we'll have x to the 0, which hopefully you remember is just 1. So this is a constant. Polynomials have integer values that are positive. So we could have x to the 3rd, but not x to the negative 3. So polynomials, we have positive integer values. So positive integer exponents. Okay, so we've seen first degree polynomials. We call those linear because they're lines. Second degree is quadratic. Third degree is cubic. So if we're going to make a cubic, we would say ax cubed plus bx squared plus cx plus d. So we got all the way down to our constant. When we look at the graph of a cubic, it has the general shape that's kind of like an S. So this is if a is positive. It's not always going to have the two bumps. Sometimes it could just be flat as it goes up. If a is negative, so positive a, negative a is going to flip over. So it's going to start up and go down. Or again, it could have a flat area. But if it's negative, we start from infinity and go to negative infinity. Positive, this way. Remember from quadratics, if we see something that's in factored form, well, that's showing us our roots. So in this case, again, if a was positive, it would point something like this. And now if we put in some axes, let's try that again. All right, there's my straight line. And somewhere over here, let's put in a y-axis. So in this case, my three roots would be P, Q, and R. Over here, my y-intercept, well, that's when I plug in 0 for all my x's. So I would get a times negative p times negative q times negative r because I would have zeros here. So that's how I would find my y-intercept. Remember, we plug in 0. So if it factors into this way, I would have 3 roots. If it factors and 2 of my roots are repeated, well then, this is fun. It looks like this. So now I would have my shape go something like this. So now that's where my P would be because I bounced off the axis. This is where my Q would be. If it repeats 3 times, that's when I get something that's similar to my flat shape. So repeating 3 times is going to look a little bit, I don't know why my line is not making lines. Oh yeah. There we go. So if we repeat 3 times, now it's making lines and I don't want it to. Oh my goodness. That's when we get our flat bit coming through. So this is not quite accurate. My flat bit should be on the axis, but you know, I'm having trouble with my line drawing. So this is where my P would be coming into my flat bit. Again, to find the y-intercept, we plug in 0 for x. Okay, so try to apply this knowledge to what you think these graphs are going to look like, and in the next video I'm going to show you.